Hello class, just a couple more weeks left to this semester. This is week 10 and this is the week you need to be finishing up your exam number 3. Make sure you ask questions, make sure you understand everything that's on the handwritten review to make sure you are prepared to take that exam, and if you haven't already taken it, it must be completed by this Tuesday. This week we're covering more types of problems dealing with quadratic equations. We're going to be covering completing the square and 2 other methods for solving a quadratic equation. If you have any questions about it, please make sure you ask. I want to jump over to the handwritten review that you've been working on, and I want to make sure that you follow the directions. I really don't want to receive these sheets of paper with all the problems on it. You should be writing each question out and solving it. When we're finding the square root, in some cases you can use a calculator, but I would like you to be able to do it without a calculator, simplifying and knowing the rules for finding square roots. There are rules that are applied that deal with quotients and by products, and those are rules that you need to know. Like taking the square root of a negative number, you can't take a square root or any even root of a negative number. So make sure that if you have something like this, that your response is going to be there is no solution. There is no real number that is the square root of negative 144. Using your calculators to finding square roots, you're going to round and make sure you read directions so that you are knowing what place to round your answers to. Some things to note about exponents. Make sure you know that a rational exponent or an exponent that looks like a fraction doesn't mean that the term is a fraction. A rational exponent is actually telling you what the root is or the index is using the radical symbol. So the exponent of 1/2 just means the square root. An exponent with a denominator of 3 means a cube root, and so on. Make sure you understand negative exponents. Again, have nothing to do with a negative number. It doesn't turn the base into a negative number. A negative number in the exponent means that you are taking the reciprocal. You're flipping that number, putting 1 over 36, and then taking the exponent of 3/2. Let's go through some other things here. Dealing with exponents, there are a lot of rules. I highly recommend using index cards to write down one rule on each index card to help you remember. Here's one right here, number 17. We have a negative exponent, which means that we're dealing with a reciprocal, or 1 over 32. We also have a negative sign out here. When we apply the exponent, we're not applying the exponent to that negative sign. So our result is going to be taking the negative or the opposite of what we get when we take the 4/5 exponent or 4/5 power of 1 over 32, because that negative sign in the exponent means that we're not dealing with 32 as the base, but we're dealing with 1 over 32, the reciprocal of 32. Make sure that you know the quotient rules, the product rules, and the power rules dealing with exponents. Now, when we're working with radicals, we also have rules that are similar to the exponent rules. We have product rules and quotient rules, and when we're dealing with the square root of a trinomial, that should be a hint to you that the first thing we have to do is factor. A lot of people had problems with the factoring in the last test, and I don't know how to emphasize it anymore that factoring is very, very, very important. It is the most important part of getting through this class really and onto your next class. You need to know how to factor. So when you see a trinomial, try to factor it. When we are dealing with an even number root, we cannot take the root of a negative number. When we are dealing with an odd number root, a negative number under the radical sign is perfectly legal. Again, here's radicals that we have to deal with the product rule, and here's one where we're going to be dealing with the quotient rule. Let's see, here we've got more product rule because we're multiplying, and here's a combination of product rule and quotient rule because we're multiplying and dividing, and we're dealing with reciprocals, so pay attention to the signs and don't lose them. Here we're dealing with two radicals that have a different index. This is a fourth root and this is a square root. The only way we can deal with that is by turning these back into expressions where we have x to the 1/4 power and then x to the 1/2 power. Once we are dealing with them as exponents rather than radicals, then we can do something with them. In the current form we can't. The product rule does not apply when we have a different index. So sometimes, like in this situation here as well, we have a different index. We cannot use the product rule for radicals. What we're going to have to do is turn these into expressions with exponents instead of roots, and then we can apply the product rule for exponents, if at all possible. This one, not sure if that's going to work for you. This one, the rules for exponents will. Pay attention to those, and if you have any questions about them, please ask. Product rule. Sometimes we're going to have to multiply things together and then use the product rule underneath to break them out and simplify them as much as possible. Quotient rule. We can simplify underneath the radical first, or we can break it out into two separate radicals. I highly recommend simplifying within the radical symbol first. Here, since we have two separate radical symbols, but we are dealing with the same index, we can use the quotient rule to break this into one big cube root, to simplify what we have underneath that cube root, and then we can break it out and simplify it. Let's see what else I wanted to talk about. Right now, in the current form, we cannot do a subtraction of two radicals because they are not like terms. But if we simplify this by finding different factors of 112 and using the product rule to simplify this radical expression, same thing here, then hopefully we will wind up with two like terms with the same value under the radical symbol. Here we have regular multiplication, but here we're going to be distributing that square root of 7 times square root of 3, square root of 7 times the square root of 5. This one here is one I want to make sure you understand. Oh, let's go back to number 50 first. What we have here are two binomials. I know it kind of came out a little bit funky on the paper, but we have the square root of 12 plus 2 times the square root of 12 minus 2. Two binomials. You're going to FOIL them. There's also a special rule that we can follow if you recognize that we have the sum and the difference of two of the same terms. Here we are squaring a binomial. This does not mean that we can distribute this exponent to each term. No, we can't do that because it's a subtraction. It's two separate terms inside. What this means is this binomial times itself. So this would get written again so it looks more like the problem above it. And then again we would have to FOIL. Again, we're dealing with like terms in order to combine them. When we have here a fourth root of 6 and here a cube root of 6, they can't be combined even though we've got a 6 underneath. So the only thing we can do to work with them is turn them into exponents and see if we can combine them that way. Conjugates. Conjugates come in handy. All it is by changing the sign. So instead, the conjugate of 3 minus the square root of b is going to be 3 plus the square root of b. Rationalizing the denominator. We're going to be using conjugates here. Keep that in mind. We don't want to just multiply by the square root of 6 over the square root of 6 because that doesn't leave us with eliminating the radical underneath in the denominator. So we have to use conjugates here. Very important. No, here I cannot cancel out terms. These are not terms that can be canceled because these are not factored. They're two separate terms in the numerator, two separate terms in the denominator. Equations. What you have to do is, I just saw some problems that you don't have to worry about. When we have two radicals in there, it's a challenge, and you are not responsible for being able to deal with equations that have two separate radicals in it. So don't worry about those. But 66 through 70, make sure that what you are doing to one side of the equation, you're doing to the other. And in order to get rid of that radical symbol, you want to undo it. Whatever you do to the left side, you have to do to the right side. In order to get rid of a square root, we're going to square it. In order to get rid of a cube root, we're going to cube it. But don't try to cube this until we separate and isolate that radical term by adding 3 to both sides. Now when we get down to complex numbers, that's one place where we can deal with the square root of a negative number. The one thing and the most important thing I want you to realize about complex numbers is that imaginary numbers only has to do with the square root of a negative number. If we're dealing with a fourth root or a sixth root or any other even root, we cannot take that root of a negative number, and it has nothing to do with the complex number, or I, which is defined as the square root of -1. If you have any questions about any of the problems on the handwritten review, please ask. And if you haven't taken the exam yet, please make sure you understand how to work these problems before going in to take the exams. You can post questions or you can send me an email and I'd be happy to help you out. Good luck and talk to you soon.